So this webinar is going to be about energy performance contracting and how it might fit into the StepUP methodology for deep renovation. Maybe, Marina, would you be able to share the agenda? Okay, so first, yeah, okay, thank you. So firstly, we will present the key features of the StepUP project and their underlying processes and technologies for deep energy renovation. Afterwards, secondly, we will provide insight into the smart EPC performance-based model, which focuses not only on securing energy savings, but also on multiple benefits like improved comfort and quality maintenance. And then finally, we will be showcasing two renovation projects addressing deep renovation based on the StepUP type integration model. So the first speaker is Amisha Panchal from IES. Amisha will be introducing the StepUP project, and Amisha is project manager at IES and is coordinator of the StepUP project. Amisha, please go ahead.
Thank you, Miguel. I'll be sharing my screen now. Okay, let me know if you see it all well.
Yes.
All good, Miguel?
Yes.
Okay, great.
Yes.
Thank you.
Perfect.
Okay, great. So good morning. Thanks for being here. I will be giving a short presentation about the StepUP project and about IES before we dive into the smart EPCs. Okay, so as Miguel said, I'm a project manager at IES, and I would like to say a few words about IES first. It is a software company that is also involved in consultancy and research projects. The key software and tools that IES develop are focused on measuring the energy performance of the built environment at different building scales, so from building level to master planning level using physics-based modeling. The vision that IES believes in is that every building can be decarbonized and then works on a technology to make this possible. At the same time, balancing the different environmental and comfort metrics to get there. Within the project, IES is working on intelligence toolkit to support deep renovation and coordinate the project. As the project name suggests, the project focuses on the deep renovation and its market uptake. While shallow retrofits are very common and they're cheaper to implement, they bring about very minimal impact to an overall building's carbon and energy use. Currently, the deep renovation rate in EU is only about 0.2%, and in order to reach a drastic decarbonization goal, this percentage needs to increase. And the methods to achieve this, we believe, is need to be simplified, and that's what StepUP project is targeting. So StepUP proposes a deep renovation methodology with the stakeholders' needs and data intelligence, these two things at the core of the methodology. The project suggests an iterative method of deep renovation, which takes place over a number, or it can take place over a number of years, whereby the benefits from one iteration can be monitored, analyzed, and it feeds into the next iteration. The plug-and-play systems and data intelligence toolkits are developed, and these support the deep renovation methodology and enable it to adapt it to a wider market. The key objectives that the project aims to achieve to make renovation, in particular deep renovation, more attractive and reliable is by presenting analytics based on real data, reducing performance gap using a suite of digital tools, optimizing renovation investments by developing innovative financing models that we will discuss in this webinar, minimizing time on site by using innovative plug-and-play modular systems, and accelerating the renovation market by introducing plug-and-play protocols that enable interoperability between the different technologies and systems. In summary, these are the 4 technologies that are being developed in the project. Firstly, the modular facade system. So the plug-and-play module is installed outside of the building envelope, and it increases the thermal performance of the building. A flexible heating or cooling solution is developed using PCM storage, which is phase change material type of storage, and it's used with data intelligence. Both of these technologies are developed alongside the plug-and-play protocol. Which offers the capability to integrate with different components, which can be active systems or passive systems, such as windows or different finishes, solar protection, shading systems, existing HVAC systems. And because these are modular and plug-and-play systems, they also can benefit from pre-assembly and using less time on site and less disruption to occupants on site. Innovative financing tools for deep renovation, which is the smartEPC that we will talk about. The development of a building value model was aimed to stimulate the renovation investments and work on a substantial barrier that we currently have to deployment of deep renovation and all of these innovative technologies. So that is a key part of this renovation process. Finally, software and tools were developed further in this project to enable this integration of digitized physics, artificial intelligence, and machine learning models. Within the project, the StepUP is developing a tool for the creation of a digital twin to analyze all the various different decarbonization options, identify and weigh up the risks and potential savings prior to implementing and monitoring these savings towards the net zero targets over time. So these are the main technologies that are being developed in the project and it's being applied to the deep renovation methodology. So I want to quickly show you a short video of installation of the plug-and-play facade system. I will speed it up just a bit. Okay, so this was applied on one of our pilot sites, which we will also talk about in this webinar. The production of sandwich panels and ventilated facade systems already existed. One of our partners, Money Green Tech, has an expertise in the light steel. I'm sorry. I'll just go back a bit. Yeah. So one of our partners, Money Green Tech, already has an expertise in the light steel frame structures, and the combination of the two solutions was never studied beforehand, and it's innovative in the market. So this implies that it must be technically validated with prototypes, which was done in this project. This new envelope uses a structure that is provided by our partner Money that can easily be attached to existing slabs of the building without affecting its structural balance. The solution developed consists of the creation of highly customized, industrially produced plug-and-play modules. The two main elements of the solution are the anchoring system and the modular elements, which are the light steel frame structure, thermo-insulating sandwich panels, and an external layer. The anchoring system has been deeply developed during this project, and it has defined a solution which doesn't only allow the horizontal, but also the vertical movement of the modules and also the adjustment in the direction of the facade. Monitoring systems or electrical or thermal systems with the piping can also be integrated within this facade. So thank you. Right. So the next system is the plug and play active system. This uses an integrated solution with the phase change materials, like I mentioned before. And it's combined with renewables such as PV panels, commercial heat pumps, and advanced optimization and control logic to operate these charging and discharging of the tanks. The integration and application of these systems are being studied in the project and will be implemented on the pilot sites. And this is aimed to ease the installation time, the installation process, and the data intelligence supports the overall approach of StepUP methodology, which is very much focused on data intelligence throughout the renovation process. The plug and play solutions are not as adaptable in the market without the technology provider clusters. So these are all the other third parties such as the solar shading and PVs and the heating systems that are already existing, which have the potential to be integrated within these plug and play systems developed in the project. So the integration of the passive systems in the plug and play module has been taken into consideration, as well as the active systems have been taken into consideration. So we can these are suitable for integration with solar shading, windows, and potentially other passive systems. They can be also pre-assembled with or without windows, depends on the project requirements. Currently, we are also able to integrate foldable and adjustable blinds by another third party in the facade. And this kind of solution basically allows slats which can be oriented from different angles and can be moved up and down, achieving a total closure if needed of the window. A suite of digital tools that are used across the different steps of the methodology are brought together in a project management platform, and it consists the final product consists of a life cycle platform. Here you can see how the different StepUP renovation phases, going from feasibility phase to the final operational phase, are brought together in the portal. And at different stages of the portal, different software and tools are available for the stakeholders to use. So this was something that was also developed within the project. In terms of the tools and software themselves, different tools were developed for different purposes. Here are a few examples. So on the top left, you can see a dashboard that allows the end user or the occupant to vote on a thermal comfort of the room. With the monitoring system that was also installed in the project, sensors and metering system, a detailed calibrated physics-based model can be created with a baseline. And this model can be seen on the the bottom right corner. And based on all of this information, a machine learning model was created that can predict the thermal comfort in a space in a particular scenario. And yeah, so this machine learning model can basically be used to predict the scenario of thermal comfort in any given situation. And this is also based on the preferences of the user because they voted for this. In the top right image, you can see the analysis of the monitored data in the building for comfort as well. A fall detection service was developed that detects anomalies such as high CO2 levels and provides some insights on what could potentially be the fault and if there are any other faults within the building which may be linked. In this case, I think there was a neighboring room that also experienced high CO2 levels, and it was concluded that that part of the building was quite deep and it was not well ventilated in this case. These are all based on pilot applications. And on the bottom left image, a district level model was developed in the project for the Budapest 18 municipality, and it's currently in the validation stage, and it aims to provide a high-level guidance for the municipality stakeholder to analyze different ECM measures at a district level during the feasibility stage. So you can see the different colors here very lightly. We're not going to go into the detail, but at a very high level, the municipality can weigh their options about different ECM options and also the different buildings which are in the need of deep renovation and make the decarbonization suggestions accordingly. Finally, the project develops the concept of smartEPC in deep renovation as an innovative financing model. But I don't want to give away too much information here just yet, as we have the webinar dedicated to this topic. So I will allow this to be discussed separately. Thank you for your attention. If you have any questions specific to the StepUP project, feel free to ask me in the Q&A session or even afterwards. Here's my email address.
Thank you very much, Amisha.
Thank you.
We go to the second speaker. Lieven will present the smartEPC integration within the StepUP renovation processes and technologies. Lieven is senior partner at Energy Invest, and he's also president of Belesco. Belesco is the Belgian association of ESCOs, which is actually grouping the stakeholders involved in energy performance contracting in Belgium. Lieven has also developed or co-developed the smartEPC methodology and has, over his career in the energy world, facilitated different smartEPC renovation projects in the public building clusters. Lieven, please go ahead.
Thank you very much, Miguel. I'm sharing now my presentation. I hope everybody can see it. If not, just let me know. Yes, just if you want to know more about our activities at Energy Invest or what we're doing with the Belgian ESCO Association, just have a look at the websites. There you can find the information. smartEPC integration with StepUP renovation process. The goal is really to share some of the insights of how we went about integrating what is basically, as Amisha explained, a phased and iterative renovation process into the smartEPC methodology, which already existed for many years and is used to renovate buildings. And that posed some challenges, but also brought some opportunities. So quickly, what is smartEPC? Well, EPC stands for Energy Performance Contract. So it's a contract. It's a contract between the building owner and the so-called ESCO to implement energy saving measures and by extension to renovate a building to a more or less degree of ambition. And as such, it becomes really a delivery and financing mechanism for energy renovation, mainly of public building stocks. That's where it's used, but the principles can also be used, of course, in private buildings. And it brings some advantages if you compare it to the classical renovation methods. And I will come back to that in a minute. In that sense, it's an evolution, a smart evolution, if you want, of the energy performance contracting model that has been around since the mid-80s and mid-90s, even in Europe. But so we added certain features. And what we also did is standardize a lot of the tendering principles, the procedures, documents, and templates to make things much easier, basically. If you look at this classical approach, I think it's good to have a look at that. And where you see on the left side, different steps that are often taken to come to a building renovation, then you see that all of those steps are typically done separately and by involving separate parties and companies. Starting with an energy audit very often, with an energy auditor, then often have to go into some kind of a design phase or an engineering phase. Often happens with an engineering company. Technical specs have to be developed to be able to do a public tender or a tender in general. Then measures are being implemented and rolled out. Often they do not include maintenance, so you have to have a separate maintenance contract with a maintenance company. And then if you look at the follow-up, well, very often there is no real follow-up. How much is being saved, if any. And even though the customer typically can be assisted by an engineering company, you still have all these separate steps with different actors involved, different contracts that you have to find. So there is a lot of lack of alignment between these different steps, and there is no knowledge transfer very often between the parties. And very often, or let's say almost all of the times, nobody is really taking responsibility for the result in terms of the energy savings. And the auditor will make an estimate, the engineering company will maybe refine that. Very often the company that is installing the technologies, or the contractor who's doing the installation works, for example, nobody really takes responsibility of the real savings once that the project is then implemented. Also, it's very input driven. Everything is based on technical specifications at different levels, and that technical knowledge just doesn't go through the project necessarily. And it leads to very often savings that are much lower than expected. Not in the least because of the maintenance part, where there is no real incentive to do savings. And when you know that a lot of the savings really comes from how equipment is being managed, commissioned, recommissioned, how there's need for if not daily, at least monthly or annual follow-up and fine-tuning, that really doesn't happen. And that's where often the difference is being made with the EPC contract. This is true for one building, but if you do this for many buildings, and that often is the way that we try to do it also in smartEPC, working, for example, for a municipality that has 10 or 15 buildings, with an EPC, we integrate all of those buildings into one single project and into one single contract. Classical way, you have to do 5 or 6 or 10 measures in 15 different buildings. So you just multiply a lot of the contracts. And even though you can group certain measures, maybe it still really gets very complicated and then labor intensive also. So the EPC approach was developed to simplify this and have one single entity, the ESCO, the Energy Service Company, putting him in charge of all of the different steps. He does his audit, and he does it in a way that he can guarantee the results. He does the detailed engineering. He implements the measures. He will do a typically long-term maintenance contract, and he's there to monitor the results and deliver on them and pay penalties if the performance is not reached. And so the customer eventually signs the EPC contract with the ESCO. And okay, let's face it, a lot of customers also don't necessarily know how to go about doing this. And that's where a facilitator can come in. It's typically one of the roles that we play at Energy Invest. As Miguel mentioned, I myself and my colleagues facilitated a lot of these EPC projects and contracts. So the guaranteed performance is an obligation of results, not just of means. It also means that we work very much with functional and output-driven specifications, and needs also to control it. Sometimes people think, I'm losing control because we're outsourcing our renovation and energy management to the ESCO. But the contrary is true, because a lot of it is based on output specifications, on key performance indicators, on service level agreements. You gain much more control, in fact, over your building and how it's performing energy-wise, but not only energy-wise. So it really is also about shifting, of course, that performance risk away from the customer to the ESCO, who is supposed to be an expert in doing such renovations. And luckily, very often they are. We also put the performance in the heart of the competitive process. It's not just about signing a contract with one ESCO immediately. In the private sector, that can be the case, but of course, in the public sector, ESCOs are being put in competition, and you select the one with the best performance overall, which was also a different approach, of course. It also means that typically it will go faster than traditional implementations, and you get quite a lot of economies of scales. There are also some concerns or some pitfalls. It's not only riding into the sun, but it's also requiring some shift of mindset. And there may be some mistrust towards ESCOs, thinking, okay, this is just too good to be true. So you have to manage that typically also as a facilitator. There's also a risk of focus on very short-term gains, particularly because the original promise of EPC was that investments were being paid back by savings. Now that is still the case for, let's say, shallow renovations. If we go to deeper renovations, which is of course the goal, and also in this project, the payback times really get much higher. People don't want to necessarily sign very, very long-term contracts either. So you have to accept that there is still a significant part of investment that has to come from the building owner himself. That just cannot be reimbursed from savings. Yeah, so that's a change in mindset. Also, you have to resist the temptation to be input-driven and to start putting in a lot of technical requirements, while as you should, as much as possible, let the ESCO make the technical choices to guarantee the performance. And of course, if the projects get very big, also the decision process may be a little bit bigger. But still, a lot of advantages that we see, and many people who have been involved in such EPC project implementations are quite positive towards the model. So if you look at then smartEPC, it's of course EPC, everything around energy performance. But then we've taken it a bit further. First of all, we've defined a whole set of different key performance indicators that the ESCO has to comply with. Has to do with energy, but it also has to do with comfort levels. It has to do with security. It has to do with documentation, with the condition of equipments during and at the end of the contract, and so on. And basically that corresponds to a fixed price that the customer is paying every quarter or every year to the ESCO. And typically there are energy savings that are then managed with like a bonus and a penalty, a bonus and a malus. That's classical for EPC, but we've gone further, also allowing to make the comfort performance bonus malus based. Yeah. Also building certification, for example, BREEAM or LEED certification, setting targets for a certain level of improvement. And then we have developed out of the maintenance mechanisms the capability of defining a building value. It's like an in situ building value, a technical value that is being calculated based on the condition scores of the maintenance program, and that allows also then to steer on this building surplus value, aiming for a higher or lower rest value. Basically, that's what it's all about. So this is some of the elements that in smartEPC have been added to the basic EPC model, with different bonus and penalty performance payments. So why is smartEPC different from other EPC models? And maybe a few more words on that. As I said, in EPC, also the maintenance has been designed to be performance-based. Classically, maintenance is also done with input specifications. So customer specifies a whole set of things that he thinks that need to be done in terms of maintenance. And we figured out that that was just not a good way of doing it. And so we went shopping in the Netherlands, where a standard was developed several years ago, the NEN 2767. And so, as I said, it works with condition scores. So every element in the building gets the condition score based on this standard, on this norm. And then the ESCO, which acts as maintenance company, has to deliver a certain condition score ranging from 1, which means a very good condition, to 6 is a very bad condition, and you have to replace the elements throughout the whole ESCO contract. And that's a significant difference. And it also leads, of course, to much more proactive maintenance, and of course also the corrective maintenance if needed. It's also very much designed around and based upon total cost of ownership. So we're not just looking at costs. And also in public tenders, very often, public users will focus on how much does something cost. We're not doing that. We're looking at the costs, investments, maintenance, maybe financing costs, but we're also looking at the energy savings. And it's the total cost of ownerships in terms of the benefits and the costs and the expenses, the costs basically, and then the benefits, which are the guaranteed savings. And we're looking at the full picture over the life cycle of the project or even the life cycle of the building. Whereas in classical EPC, even though it is performance-based, often there's just a look at the energy savings as such, or a partial use of the TCO, the total cost of ownership principle. In smartEPC, so we included this building asset value concept, thanks to the maintenance that is not used in most other EPC models, although there are some exceptions. Also, very much the design was done in collaboration with ESCOs, at least in the initial design phases. So to take into account their concerns in terms of legal clauses, but also risks. And then we use, as I said, a lot of smart KPIs, and there's a whole set of service level agreements, which again is often limited to energy in the classical way. Another part is that all the administrative and legal aspects are serving the goals of the performance contract. And so we integrated those into the specs, rather than having a separate legal contract, which often then turns out to be a big hassle for parties to agree on. If you have 100 pages of legal clauses, that doesn't work very well either. And there's a strong process optimization that we try to get into the facilitation process. Okay, these are just a few snapshots from the smartEPC tool. So there's the contract with all of the performance-based specifications, and then we use an Excel-based many sheets, to define, for example, in the upper part of the screen, some of these KPIs in various categories. And then below you see, for example, a screenshot of how a condition score measurement works as part of a maintenance. So you see on the right side the different color codes corresponding to the scores from 1 to 6 for different installations. So what are and have been the challenges for deep renovation? Because that's what we try to do, of course, in StepUP, is go also a step further. We had some experience with deep renovations, but not so much yet. And the first one is to integrate the architectural and material requirements into what is, as I said, basically a functional and a performance-based specification. When you replace a boiler by a heat pump, the idea is that you're not so much concerned about how does this heat pump look like and which specs it has. It's important that the energy savings that the ESCO is guaranteeing, that they are there, and that the comfort is being delivered by the installation. And so the ESCO has all of the incentives to pick good equipment. Because if he has to manage the installations for the next 20 years, he's not just buying some cheap equipment. But now you are talking about replacing windows, you're talking about finishing maybe roof installations. And so there's a lot of practical and visual aspects that you have to integrate that were not there when you did only shallow renovations. It also means that we have to go beyond the original concept of EPC and even the first versions of smartEPC, because we have to look much more at those multiple benefits, because they are part of making the business case. It's not only, as I said, going to be anymore the idea that savings pay for the investments. You have to now invest more, and you're not getting that return on investment. So you have to motivate it by other multiple benefits, and set also expectations in that sense. And so that's a challenge as such. So that's why we go further in managing those multiple benefits. I already said that the budget neutrality, the investment neutrality is a bit less easy, of course, to obtain. So you have to focus on optimizing the total cost of ownership in a more generic way. And then integrate, of course, innovative building envelope solutions. That's the case with StepUP, as Amisha explained. We've been working also the last couple of years, the last 3 years, on another type of project where I will be presenting a small business case later on, so small case study. And then off-balance solutions, because if we know now that a lot of public authorities don't necessarily have the money to invest or cannot necessarily borrow that money. So there are also innovative solutions we've been working on to keep things off balance. And of course, attracting new players, people that are capable of implementing such building envelope renovations into the ESCO market. And that's one of the things we're doing with the Belgian ESCO Association. So what has been implemented in smartEPC in terms of deep renovations already? Extending the building value concept, so to integrate longer term contracts. A couple of years ago, contracts were 10, maybe 12 years. Now we're moving into 20 years, even longer. Next projects will be even 30 or 40 years. And of course, developing also and working on integrating existing renovation models. One of the things we did is we disconnected the contract duration from the payback times. Before, you would have a contract and it would have like a 14-year payback time, and then we did a 15-year contract. And that's how you also got to the investment neutrality, for example, getting investments being paid by savings. Now that's not the case. Sometimes we will have projects, and it's already happening, where you have 60-year payback time, for example. But we're not going to sign 60-year contracts. We may sign a 20-year or 25-year contract on a 60-year payback time. So we are disconnecting both. And then developing new libraries of standard technical requirements. As I said, you cannot only do performance-based anymore. You have to define certain minimum technical requirements, particularly on the building envelope. And so we have been developing those. Also integrating the role of architects. And you have the architect at the customer, but also at the ESCO level. And sometimes the facilitator has to use an architect. So their role and how they interact has to be much more included in the way of working. And then the off-balance solutions compatible with Eurostat rules, I mentioned them. So why are we integrating what is, on one hand, the smartEPC model and then the StepUP methodology in the first place? Well, it's what we said that we would do in the grant agreement. So once you write it down, you have to do it. But of course, there is also a sizable opportunity, we believed, for StepUP technology partners to address a segment of the renovation market that is performance-based, and that is this ESCO market, which is also growing. On the other hand, offering performance guarantees or joining maybe ESCOs that do so can bring added value to some of the customers. And so can long-term maintenance contracts. If you're delivering a heat system, it's less the case for the facade modules, but if you're delivering a heat system and behind it, you can also do maintenance for the next 20 years, that can, of course, be of added value to the partner who delivers those heat systems. And then, of course, well, in any case, ambition levels need to go up. And with smartEPC, we just need solutions for doing those deeper renovations, and StepUP is one of them. Also, it's very data-driven, StepUP. It has this iterative process, and so it's well suited to turn it into performance-based tendering and contract models, which is, by the way, also the case for other holistic and integrated building models. So we looked at some different ways of doing the integration, ended up basically to say, okay, let's start from the basis of smartEPC. Let's make the smartEPC model better suitable for deeper renovations and integrate some of the StepUP principles in it, rather than, for example, the other way around, which we also looked at. And the challenges that we faced and face still to some extent are, of course, related to the challenge to address this deep renovation. It's the technical specifications that we the aesthetic and other type of specifications that we have to add on top of the smartEPC performance-based specifications. and develop some generic requirements while still allowing for competition in the public sector. You cannot say, okay, I want to do a StepUP / smartEPC project, and there's only one party or one consortium that can respond to that. You have to define your requirements in a more generic way so that at least potentially more parties can respond. And there will be, hopefully, also other parties on the market. There's also, of course, the adaptation for use in private and residential sector. smartEPC today, we only do for larger buildings and to some extent for social housing, but there again, you have many buildings, so it's a certain size of project. Whereas StepUP would also probably be able to do smaller projects, and how do we adapt to those? Same for multi-apartment building renovations. And then there is, of course, the fact that the StepUP process is an iterative design cycle, whereas smartEPC is typically a one-step approach. And we do most of the measures on day one, or at least in the first year or first couple of years. And then we manage performance and guarantee performance for the next 15 or 20 or 25 years. And so there is a little bit different approach there also. And then it's also about aligning project phases, and particularly the tendering phases, which are somewhat different in any case. Without going in all of the detail here, these were some of the adaptations that were required to make a StepUP-proof smartEPC model. Of course, a lot has to do with this performance-based maintenance. And there are typical maintenance activities in the StepUP methodology and that we needed to integrate in the performance-based maintenance. Also identifying typical defects, for example, allowing for easy condition scoring. And the condition scoring is based on visual inspection and identification of defects. Well, if we know upfront that certain defects are more common and may happen more often, we can already integrate that into the condition scoring methodology. And of course, also determining typical lifespans for StepUP technology. Those are well known for other classical technologies, whether they're in HVAC or relighting. But we also had to look at them for the specific technologies. The building value, I mentioned it, using that as an asset value evaluation maintenance, mainly to justify also why we're doing this more qualified performance-based maintenance, because it will still be more expensive. We have to be honest about that. But as I said, it will also deliver better value at the end of the contract. And then the financing mechanisms, there are 3 classical financing mechanisms. We also had to develop and extend on the off-balance financing, the whole planning process, the comfort management, how we're using the smartEPC principles and the specific smart KPIs. They have not been tested, by the way, in the pilots. And a good thing is that we did not have a lot of changes in the way we go about doing the measurement and verification. And measurement verification, that's how you measure and verify energy savings throughout the project. And then finally, what we did is we applied also this to some extent to pilot projects and to the technology partner clusters, and also looked at, okay, what's the status in different countries? You know, how mature is the market? What are some of the barriers or the opportunities to implementing smartEPC with StepUP in different countries, not only the pilot countries, but other countries too. And so we did some surveys, trying to understand better what's the status of market development. Is there already performance-based maintenance and so on available in different countries, and assess basically those market conditions. And we looked, of course, at different types of buildings, different types of technologies, and different types of KPIs. Some conclusions. First of all, we think that we were able to at least partially validate the conditions for developing the smartEPC model, integrating these key elements of StepUP. It's not as if, we can now say we can steam ahead in every European country with smartEPC and doing StepUP renovations. There's still some development work, of course, to be done, but at least the principles and the concepts have been validated to a high extent, with some additional work to be done. A key limitation is, let's face it, is still the use of the NEN 2767 method. It was designed and is being used extensively in the Netherlands, also in Belgium. You have some similar implementations in the UK, but it's not yet a widespread methodology. And although you could imagine, of course, doing an EPC without such a performance-based maintenance, it's still an intrinsic part of smartEPC. So that's probably something then that has to be worked at different national levels, is to start using those performance-based maintenance mechanisms. Yeah, in general, added value will be achieved by different stakeholders, we believe, by using the performance-based EPC features. There are not so many technical barriers, and that's because smartEPC is performance-based, and the technical implementations are there to serve the performance goal and not the other way around. There is certainly some work needed in terms of defining the future role of partners in the EPC and renovation value chain, figuring out, okay, how are partners going to work with ESCOs, maybe become themselves ESCOs or part of forming an ESCO consortium. And that's not just something, of course, for the home country, but it's also something that has to be done almost on a country-by-country basis. And then finally, there are some pilots that have been implemented, but not one in Belgium. So it could be useful maybe to do at some stage also a pilot in Belgium, learn more about how integrating those the new model in the Belgian specific context, where we have, of course, smartEPC, where we have performance-based maintenance, and just learn from those real-time implementations. So that's it for me. Thank you for your attention, and if there are questions, you can also answer them later in the Q&A session.
Thank you very much, Lieven. We are a little bit ahead of schedule, which is always very positive. So I suggest that we move on to showcasing the Hungarian StepUP pilot project. This is being done by Sofia Regula. She's project manager at BP18, Budapest 18, and she's overseeing the constructions around District 18 of Budapest. And she coordinates the Hungarian pilot in the StepUP project. Sofia, please go ahead.
Thank you, Miguel. I'm going to share my screen right now. Is it okay? Can you see it?
Yes.
Okay. So good morning, everyone. I would like to start also by saying thank you for being here today with us. My name is Sofia Regula, and I am here today representing BP18, which is basically the municipality of District 18. So our Hungarian pilot, the Zöldliget Kindergarten, is located in Budapest, Hungary, more specifically in District 18. Our building is more than 70 years old, so it has long suppressed its prime. The renovation had a lot of challenges, 415 square meter facade and the heating system that is not only obsolete, but also absolutely impractical. There is an existing open combustion and atmospheric standing furnace, and it's coupled with a 60-year-old cast iron radiators. So it was nearly impossible to regulate temperatures in each room. And it affected nearly 100 children, some of who are living with autism. So understandably, during renovations, moving the children was not an option. So we renovated with a fully open kindergarten. To tackle this complex issue, we implemented a two-phase approach using the innovative StepUP methodology. Our selection process, facilitated by the portfolio overview tool, led us to Zöldliget Kindergarten. So it was a representative case highlighting the urgent need of deep renovation in public buildings. So this method, the portfolio overview tool, it displayed basically the overall picture of our district's buildings and ranking them by their current condition and how well they need the renovation. So we also introduced data intelligence by incorporating an array of sensors, including carbon dioxide, humidity, and temperature sensors within the classrooms. And these, coupled with the technology that tracked the opening and the closing of doors and also the windows, played a pivotal role in our project. By analyzing this data that we collected, we were able to devise a heating and a cooling schedule that not only can enhance energy efficiency, but also can significantly improve the overall comfort level in the kindergartens. This approach allowed us to monitor and measure the impact of our renovations with much precision. So throughout both phases, we conducted a comprehensive comfort survey using tablets fixed in each classroom, as you can see on the pictures. Yes. And it allowed us to measure thermal comfort 3 times a day. So basically the kindergarten nurses and teachers in the morning, in the and in the afternoon, they tapped the screen and they told us how they are feeling at the moment. And by comparing this subjective assessment with the ambient sensors objective data, we were able to calculate the total comfort experience in the kindergarten. And simultaneously with this, we started to measure the gas consumption in advance, in very advance. So it provided us valuable insights into the project efficiency. Okay, so here I'm gonna present some pictures about how the kindergarten looked like before the renovation. It may seem nice at first glance, but the kindergarten's walls were weathered and they were worn down. A critical concern was the heat loss and the facade, on the facade and on the roof, rendering the building an inefficient energy consumer. The walls were all cracked and they were very unstable, so without proper insulation, so they basically left the interior exposed to the external elements. So in the first phase, we introduced the plug-and-play envelope system with laser measured prefabricated wall insulating modules. And later also the roof also got a traditional insulation, but it was not direct part of this project. So after several preparatory works, such as dismantling the entrance canopies or relocating the terrace pergolas and raising the wall height of the main facade with steel structure, the first step was to measure the location of the panel fixing brackets, and then we fixed them on the facade. During the planning phase, the experts carried out several measurements to verify the load-bearing capacity of the walls. And we also tested the load-bearing capacity of the roofs before putting on the solar panels. And after that, the prefabricated thermal insulation panels were installed, and they were provided by Manni, which Amish mentioned before. And to eliminate the thermal bridges, the contractor closed the door and the window junctions with additional mineral wool insulation, and then closed that with a HPL sheet. Okay, so as you can see on the pictures, the outer covering was provided by a colored cut-to-size HPL plate, and it is attached to aluminum profiles with pop rivets. And also the windows were given uniform metal elbows. So thanks to this technology, the number of on-site work process can be minimized, and the need for human resources is also reduced. So the contractor can get things done so much faster. And this technology not only saves time, but also reduces disturbing environmental factors such as noise and dust created by the renovation. And by using this prefabricated solution, the risk of errors arising from on-site construction can be minimized, since the individual elements are made in a factory under conditions subject to a strict quality control. So this initial step laid the foundation for a more sustainable and comfortable environment. This was all achieved using the Lean tool, which is also part of the StepUP methodology. With Lean, we measured a lot of things, their time on site and the amount of incorporated material. So it was basically a new platform for communication and transparency, ensuring minimal disruption to the kindergarten's operation. So moving on to phase 2, we implemented the plug-and-play active system and third-party heat distribution, including PV elements. This phase introduced a new technology featuring building energy management system-driven heat pump and an intelligent heat tank. So in the second phase, the entire mechanical system will be renewed. It will be operating during winter with new and modern radiators, and cooling during the summer months with the fan coils, as you can see on the pictures. So the electricity demand of the plant heat pumps will be provided by solar panels, and as a technological innovation, an intelligent thermal accumulator system will also be installed. So this phase is still in progress, but thankfully both the contractors and the leaders of the kindergarten are very collaborative at this moment. So this phase will likely end at the end of January. In conclusion, our pilot project is, I think it's not just a renovation, it's a testament to our commitment to sustainability, efficiency, and most importantly, the well-being of our community, including the children who depend on us. Although smartEPC wasn't a direct part of our pilot, I believe that the incorporation of this tool into future projects can not only improve the financial robustness of the business case, but also can reinforce the commitment to sustained benefits, effectively bridging the gap between empty promises, and an enduring real-world impact of the realm of deep energy renovations. As Livia mentioned before, the traditional route of choosing the right candidate, the right contractor, and then signing the contract can be really long. So in our case, we had public tendering during our pilot, and I firmly believe that it would have been much quicker and more efficient with the integration of smartEPC. So that was all. Thank you for your attention.
Thank you very much, Sophia. I suggest that we proceed to the last presentation, which is being done by Lieven Stralen. He will showcase the Belgian Deep Renovation EPC project called Sociale Energiesprong, which is very freely translated social energy jump. Lieven, please go ahead.
Thank you very much, Miguel, and also thank you, Sophia, for the presentation of the Hungarian pilot case. And as she mentioned, effectively, doing such a renovation with an EPC or a smart EPC model, of course, is perfectly possible. It just means that we would also be adding performance guarantees on the energy savings on top of the savings that, of course, are undoubtedly done with the measures that are being implemented. And so the same is the case here for the case study of the Sociale Energiesprong project. It's not part of the StepUP project. It's also not the full smartEPC implementation yet, although similar projects will and hopefully will be done using the smartEPC model fully. But we have incorporated different smartEPC concepts into the project as we went along. But let's say that the contract finally signed between the social housing company and the ESCO is a slightly different contract, but of course also EPC based. So maybe some history about Sociale Energiesprong. It is basically a specific implementation in Belgium in the social housing sector, based on the Energiesprong model itself, which has been developed some years before, mainly out of the Netherlands, also being implemented in some other countries. And the idea being to have a solution for fully integrated, what we call holistic renovation of individual houses, but in a repetitive manner. And so the typical implementation, for example, in the Netherlands, is a street of houses. Of course, in the Netherlands, they have what we call housing corporations. So a lot of public or semi-public private housing organizations that rent basically houses to individual owners, not only social tenants, by the way, also other tenants, but they're very identical. So you may have a street of maybe 10 or 15 fully identical small houses all next to each other. And the model was also to renovate such buildings in a very quick and very efficient manner. And that's that's the energiesprong methodology. It's also based on variations of those. Maybe some of you have learned about stroomversnelling. It's another similar implementation model. There's also the renovates model, which is an extension of stroomversnelling. So anyway, these are all models for renovating individual houses, but that are very similar or almost identical. And it's not something that we necessarily have in Belgium, but we do have social houses that are very similar, where you have a social neighborhood, often with individual houses, sometimes grouped together with 2 building units, maybe 4 building units. And they're not necessarily identical, but they are very, very similar in setup. And you may have 50 or 100 of such homes with social tenants inside a neighborhood throughout Flanders, Brussels, Wallonia. A lot of these buildings have been constructed in the 60s, 70s, 80s. And so they have been there for 20, 30 years, not designed for energy efficiency. And so there is a strong need for renovation from a functional standpoint, but also, of course, from a climate standpoint. So the Social Energiesprong project was a pilot project to test how can we apply the Energiesprong model to social housing in Belgium. And the project concerned 4 buildings in the city of Hoeselt, or the municipality, I should say, of Hoeselt in the eastern part of Belgium, in the province of Limburg, working closely with the social housing company called Cordium. And so what is the concept? It's similar to what you have seen in the previous pilot in Budapest, maybe with the difference that there's, of course, wall panels being mounted and developed in the factory based on the lasering of the entire building. Same for roof panels, but the panels are the size of the full facade of such an individual house. So the kindergarten is, of course, a larger building, or 50%. Sometimes there's 2 panels per facade. But so the number of panels is limited. Also, the windows are integrated into the panels, same for the doors. The solar panels are integrated into the roof panels. And there is an energy module which contains the heat pump. There's always use a heat pump. In this case, we do not use the heat tank methodology or technology, but we do use a heat pump. And that's integrated in this case on the roof of the garage. So as I said, based on previous holistic renovation models, it's an integral deep energy renovation, and so one-step renovation towards energy or climate neutrality. The whole process and method is optimized for doing large neighborhood renovations. In our case, of course, we only piloted 4 buildings. Going to a renovation of an A+ label. So in contrary to what today is happening a lot with classical renovations where we only go to a level B, even often still within a condensating gas boiler. Here we are going for full electrification, integrating, of course, also the PV solar panels, fully electrification with the heat pump, this smartEPC aspect of guaranteed energy performance, very strong focus also on social tenant participation. And we saw that in Hungary, where, of course, you have to involve the people from the kindergarten, take into account the limitations of the children. Here's the same thing. You know, there was a lot of work done with the tenants in the preparation phase, of course, also in the implementation phase. But the renovation was done in less than 10 days. And that's, of course, also much shorter than in a traditional renovation. Means that the tenants also could remain in their homes. And we basically extended the lifespan of the building by another 40 years, which makes it a really more future-proof Vision 2050 project. There's, of course, some preparation done also here in terms of making sure that the panels can be installed. There were some non-destructive tests done on and destructive tests done on the facade, so making sure that they can carry the weight of the panels. The same thing for the roofs, and that the existing tiles had to be removed. We had to check if the existing wood structure was sufficient. Of course, there was the specifics of the garage, which made the installation a bit more complicated. You have to avoid the problems with the differentiated thermal insulation. And then, of course, everything was measured via laser and designed in the factory for fabrication of the panels. There was some preparation. Here you see on the left side, you see the roof of the garage that didn't have to be insulated, but we had to check and ensure that that there was no water infiltration risk, and then prepare like a small system to carry the cabinet that contains the heat pump. So the heat pump is placed in this cabinet on the outside of the wall on the first floor on top of the garage. And of course, some cabling also had to be foreseen. This is the pictures showing how the facade panels. So you see here half of the facade. The bottom floor facade panel is being installed with a crane. Same on the right side with the roof panels. And it's this type of installation, very similar to what the StepUP implementation in Hungary has done, again with larger panels. This is a view from above during the installation. You see part of the panels already being installed on the front facade of the first building. Of course, the others still being done. And it's also a very much contained construction site or renovation site at this stage. Other neighbors have little problems with the works that are being done. Here you see how the facade panel is being lowered onto the fixation system. And then if you go to the full implementation, this is how it looked like before. Right? So you see the 4 houses with the 2 garages in between, and this is the implementation afterwards. So it's not just an energy renovation, but also visually, and it's very much appreciated by the social tenants that they are living in a much more pleasant environment. In this particular case, there was also a second project on water savings, and that's why you see an additional box, a white box on the facade. Okay, visually maybe not the best choice, but it's a pilot project, and you see some systems in the grassy area just in front of the facade. So that is for the water saving system. So it's an energy sprung and also a water sprung, if you want, a water jump and an energy jump. Maybe showing this also, it's a monitoring dashboard. Also, again, similarly to what is implemented in Hungary, for the occupants, allowing them to provide insight in how much are they consuming and at what stage. Also acting as a thermostat, setting temperature levels between certain limits, of course, because the ESCO still has to guarantee the performance, but it takes into account the flexibility they have to manage their comfort. Also setting some consumption targets, so they know, each month how well am I doing? It also monitors air quality, and because of the insulation, there is a ventilation system that has to perform well, and also managing the ventilation flow day and night mode and so on. And then finally, it provides feedback and allows for fine-tuning for other consumption patterns if there would be a change in occupation, of course, because it has to be flexible for different occupations. And then just a few numbers. So on this project, you see 89% kilowatt hours final energy savings. So that's where we're very close to a full integrated renovation with a much higher ambition level, and that's where you reach the level A. 27.5% auto consumption with the PV panels. Also, CO2 peaks are being reduced by 20%. There's a significant improvement also in floor temperature, so measured here with the difference between wall and center, at similar temperature before and after renovation, and an estimate of the solar PV production around 8,000 kilowatt hours. Financially, some data maybe, the current, say, sales price, if the social housing company would have to sell the house, it would be worth around 168,000 euros, to give you an idea. And the annual rent income for the housing company is close to 4,000 euros. They also have a current maintenance cost of 735 euros, of which the tenant himself is paying 222. The tenant, of course, is paying the energy bill, which today was around 2,528. This is an average, of course, because the 4 buildings had slightly different energy bills, of course. If you look at the investment, so doing this renovation this way per home was 123,451 euros. Now, if we would have to do this renovation to what we call an E50 level, so basically level B, it would be cheaper. Let's face it, around 80,000 euros. But then you would have to redo it again in 20 years' time. And if you would have to do it in this way in 2 steps, then the total renovation cost would be much higher. You would end up somewhere around 250,000. So you could almost do this renovation for half the price in 1 step, rather than doing it in 2 steps. Of course, also with the price evolutions, what you have to pay for in 20 years. Subsidy-wise, that would be similar. And so you see that the net present value of the renovation is about 25,000 euros compared to 1,600 in the simple renovation case, and even negative in the 2-step. Of course, that takes into account also the improved real estate value. But of course, eventually, it's not the goal of a host social housing company to sell all of its homes. Some of its homes will be sold, maybe even to existing social tenants. But in the end, that's not the goal. So here, if you don't take into account this real estate value, then of course you see that the net present value is negative for all of the cases. But that just means that the public authority has to invest somewhat in the comfort and in the climate neutrality of its building portfolio. So that's normal. But you see also here the discounted payback time around 40 years, and that's the target that we were aiming for. But if you do it in 2 steps, you would end up over 60 years. And then, of course, very important also is what does it look? What's the result for the social tenant, the people we're eventually doing this for? And you see the existing gas bill, and I mentioned 2,528 euros on average, roughly half gas, roughly half electricity. And you see that they save almost 2,000 euros per year. So their energy cost is basically cut by a factor 5, and that's very significant, of course. They have to pay an additional annual rent. There's also a system in Belgium now, or in Flanders at least, where if you have a better energy performing house to offer to social tenants, that you can modulate as a social housing company the annual rent. And there's a small saving also in the maintenance costs. So the net annual cost savings are not 2,000 euros, but they are around 670 euros. But compared to an E50 level, where the energy bill is just much higher, so it's 290 euros. So putting all these numbers together, you see that it's a real win-win situation for the social housing company to do such renovations, but also for the social tenants. And so, of course, now the government has to decide and look into deploying this type of renovation on a much larger scale. Maybe starting with a first full neighborhood renovation, and then maybe to other cities and other social housing companies. So that's it for me. Thank you very much. And if there are questions about this project, joining at least a lot of the principles of smartEPC and also of how StepUP works, even though it's different specific technology, but all of the key principles are there. I'm happy to answer your questions.
Thank you very much, Lieven. That this ends the presentation part of the webinar. So we will take now time to go to the Q&A session. We got a few questions. I repeat that if you have questions, you can either raise your hand and then you will be picked up by Marina, and your mic will be unmuted and you can ask the question, or you can still put it on the chat box. We will pick them up and then present it to the different speakers. So if I go to the first question raised, and that's a question to Amisha. How are energy savings from the individual measures like smart window blinds calculated? And linked to that, what is a typical return on investment for these deep measures? So I don't know, Misha, whether you will be able to answer to both questions, and I guess that maybe Lieven or probably or eventually myself could answer or add some comment on the answers. So Misha, please.
Thank you for the question. So part of the StepUP approach is to monitor the energy use in the building over a period of time, with at least a minimum of 1 year prior to renovation, to allow an analysis of typical energy use before deep renovation measure is designed and implemented. So in case of StepUP, we are evaluating deep renovation strategies that of course accumulate a bigger saving over time. So the calculation of the energy saving is done through the monitoring of the difference in energy use in the building before and after measure. We also developed an monitoring and verification service in the project, which is closely looking into the different metrics of the performance, and it aims to see the difference between before and after and raise if there is a discrepancy. In addition to this, we also, as I mentioned earlier, developed calibrated physics-based baseline model of the building, of the pilot buildings, which is an good way to see an accurate energy saving calculation in advance of the implementation, or even can be checked in after to validate the ECM measures performance, which is used in the MNV service. So with the use of the calibrated baseline model and the energy savings from one particular measure can be picked out, such as something like a window blind. It can be separately evaluated. Something like that may not be, for example, possible to do on the pilot site, because as is the case with the renovation approach we take, we don't want to suggest simple measures like shallow retrofits such as window blinds, but accumulation of those. So for example, overall facade improvement. So window blinds could be part of that. So an overall improvement is analyzed within the project, but if we wanted to look at one separate thing, it could be done possibly through the validated or calibrated baseline model. In addition to that, okay, sorry. So the next question is on the ROI. So this is dependent on a number of different factors, on the ECM measures, on the energy prices, on the energy requirements of the building itself, and the baseline performance of the building. In StepUP, we are working on two main plug-and-play ECM solutions. So one is the plug-and-play facade, which can start to have an ROI from 7 years, but it can be more depending on other factors. For the plug-and-play active system, the main component of that is the PCM storage tank by our partner Heat Venters, and the ROI for that is around 3 years, or can be even less than 3 years. Here, I think if anyone else from the other presenters want to add anything, feel free to do so.
Yeah, I can maybe say a few words about how we're doing it typically in smartEPC projects, and also in the social energy sprong project I presented. It's very similar. Either the baselines are being left to the ESCO to define, and then the customer provides the energy consumption data. But more and more, there's a tendency for the customer, at least with the help of the facilitator, to define the baseline. The reason being also that you have to choose what is called an M&V option. For those of you who are familiar with the IPMVP protocol, option A, B, C, sometimes D. And one of the reasons why we would leave that choice of baseline definition to the ESCO is that they can choose the option based on the energy saving measures that are being implemented. But today, very often the customer and the facilitator will suggest to use what we call an option C. So it's a global measurement of the savings and of the energy at the level of the full building. And that is much better suited to this type of full renovation very often. So in that case, it's the customer and the facilitator who define the baseline. Then the ESCO designs his measures. We'll do heat loss calculation, we'll do calculations on the efficiency improvements, for example, of the heat pump compared to a traditional gas boiler, look at the COP, and then what they will do is get all the measures together and also look at the interactivity between different measures. What if you do LED lighting? How does that reduce additional heat load or heat being produced, so you have to take into account those things. Same for the PV panel, how much can be auto-consumed and so on. So they design then the whole of the solutions and define, the customer has already defined the correcting factors on the baseline. Of course, the degree days, taking into account the weather conditions, but maybe occupation and other types of conditions. So it's very similar to what Amisha explained also. But it's really the ESCO who chooses the measures, does the calculations, and then of course with a certain margin will propose a guarantee. And maybe their calculations will lead to 85% energy savings, but they have to guarantee it for the next 20 years. So they may say, okay, we will guarantee, for example, 75%, and not necessarily the full 80. But they have to be competitive, so they cannot say, oh well, let's just guarantee 50%, because then they may lose the contract to a competitor.
Maybe as a general comment on return on investment, the return on investment is, or the financial logic behind a typical renovation project can be used in what rather shallow renovations and renewable energy like PV and wind. Once you get into the retrofit of buildings, the energetic retrofit of buildings, you get returns on investments or payback times that start being quite high. I mean, you will see return on investments or paybacks for commissioning systems below 5 years, 6, 7 years. You will see HVAC or technical installations going up to 15 years. But once you touch the building envelope, then you will see that you can get to a paybacks of 40, 50 years. We have quite some projects going on for the moment where the payback of the building envelope is over 100 years. So we don't, as energy efficiency facilitators, consultants, it's quite sometimes that we don't advocate too much to use the key performance indicator payback too much, or put a lot of attention into it, because it is less important in deep renovation. You don't get to paying back your investment with the energy savings. It doesn't work. So what we do is emphasize the importance of the multiple benefits of what does this mean to the users of the building for, you know, at the level of comfort or environment or indoor environmental quality, and all these things that make the business case attractive if you go to deep renovation.
And of course, the obligation. I mean, today, it's not a question anymore of, you know, should we do it or could we do it? It just has to be done also. And many public authorities are just faced with the obligation to deeply renovate their building stock. And that also puts things into perspective, of course. Doesn't mean that the financing is readily available. That's another solution. But also there, yeah, we're working on solutions, of course.
Okay, so Lieven, a question for you from the audience was linked a little bit to the ROI. How do you get investors comfortable with the subjective risks, e.g. comfort and surplus value, when these can impact the EPC repayments? So here we are in the model where the investor would be paid back by the EPC repayments, by the energy savings.
Yeah, well, it's normally in the end, it's always the customer who's paying for things. I mean, he's investing, even though they're using an external investor or getting money from an external investment fund. The internal investor will always look at the risks of the project, mainly risks of the customer who is eventually doing the investment. And they will get a certain fee, a certain interest rate for investing and financing the project. But so the fundamental, let's say, decision to invest and how much and how to do that is still with the building owners. The ESCO, of course, he's taking on the performance risks. So if you use an ESCO that is reliable, that has a certain experience and track record, then you can assume that the savings that are being guaranteed are there for the next 20 years. There's always some risk, of course, but the contracts also foresee different clauses in case of failure of the ESCOs. So that's very often not a big issue. But it's still the building owner who is investing, and the investor is looking at this project, typically as he would look at any other investment project. You know, what are my risks? How reliable is the end customer? How reliable are the people who are implementing the project? What's the interest rate that I can charge, and that the customer eventually is also willing to pay for? That's how it works. I'm not sure if that's an answer to your question. And of course, things like building value, I mentioned that, are more used as a way to push for deeper renovation. Because if you go for deeper renovation, for example, for insulation, the lifespan of insulation materials is maybe 40 years or longer, 50 years. And so the rest value after a 20-year contract is much higher than if you install a boiler or a heat pump, which itself has only a lifespan of 15 or 20 years. Yeah, basically meaning its rest value is very low. So that rest value is not used in let's say, as part of the business case as such. It's more used as a means of assuring additional savings beyond the contract, and as a means of justifying also sometimes more expensive maintenance contracts that you have to do there to keep the installations performing throughout the 20-year contract. But the building value as such is not a criteria or an element that the external investor, for example, will take into account. The building owner will, of course. Not sure if that's an answer, hopefully, to the questions.
Okay. Then there is a question related to the Sociale Energiesprong. The question is, who financed the renovation project for this pilot case, and what is the payback period and EPC term?
Yeah. Again, in this case, it's always a social housing company. They are owner of their building stock of social houses, and they are paying for the financing. Now, they have the possibility to get loans from in Belgium or in Flanders, it's the VMSW, it's the Flemish company for social housing. It's like an umbrella organization, a public entity that, first of all, oversees the whole social housing policy implementation, but they also provide cheap loans and even loans with a negative rate. And so that's a way for the social housing company to finance or to get external funding, public funding, not private funding, from this central organization. Of course, one of the things we looked at is, why can't we use ESCO financing? Why can't the ESCO finance? And one of the reasons would be that under certain conditions, again, not so easy to meet, but under certain conditions, the whole or a part of that financing can then be what we call off balance for the public, not so much for the housing company, but let's say for the Flemish government in this case. So it's an external ESCO financing that, according to Eurostat rules, could be off balance. That mechanism has been looked into, but today the VMSW does not really allow for it. It doesn't allow yet for housing companies to use such ESCO financing, and certainly not, in a way that it doesn't increase public debt or that it's off balance. That's how it basically the financing is done. So it's financed, but of course there is some kind of co-funding by the social tenant. As we said, there is a rental increase, and that rental increase partially also contributes to funding the project that is done by the social housing company.
Okay, thank you, Devin. Still on your side, on the Energiesprong. Are the financial energy savings for the Energiesprong project calculated assumptions or based on actual invoices?
They are based on actual invoices. So the base case was based on actual energy costs. Of course, in this case, we made an average for the 4 buildings. So you have 4 individual business cases. So we only presented the average one, but it's based on actual estimated sales costs. Of course, the building is not sold, so the sales price is estimated, but it's estimated on historical sales data of existing buildings, similar buildings, or even identical buildings. Energy bills are the real costs. Investments are the real costs that were implemented. And of course, also the savings and then the actual return are actual costs. Yes.
The EPC term was 40 years.
Yeah.
Which is very long, but as it was a project, we could afford presenting this kind of term. Okay.
Of course, what could happen is that after a few years, the social tenant moves, and then you have another social tenant. And if they have, maybe now you have a family with 2 children, and then maybe in 5 years' time, you will have another family with an older person and no children. Okay, then energy consumption to some extent may change. Use of domestic hot water will slightly change. So you would then have to redo, to some extent, the business case. But that's where things are being normalized so that the ESCO does not suffer from such changes in occupation, and that his guarantees can be recalculated, of course, once such a change could happen. And it's quite common, particularly over a 20 or certainly a 40-year period. People will not necessarily always be the same. Maybe children grow up, they go away, they go to live elsewhere. So you have to take into account those changes, of course, in reality. But it shouldn't affect the performance guarantees that the ESCO is delivering on the savings, of course.
Okay. The next question is again on the social housing, but it might be replied by Misha because it's about balconies. It says in Italy we experienced some barriers in following this model, so the social energy sprung or the StepUP type. We don't know yet. We don't know. I don't know what's referred to. But anyway, so we experienced some barriers in following this model for retrofits due to many social housing built with much details in the facades, like balconies. Misha, maybe could you try to reply how the StepUP project dealt with balconies? Or how many with the plug-and-play facade dealt with the balconies?
Partly. So we had one Spanish pilot which had balconies. In the end, we managed to design the facade system, but we haven't had a chance to implement it in the pilot. So we haven't reached that point of doing the calculations. We experienced different kinds of barriers to implementing the retrofits. So unfortunately, I can't fully answer this question from my experience.
Okay. But the provider of the plug-and-play facade actually found a solution for the balconies, right?
Technically, yes.
Yes.
From the technical side, we have a solution. From the finance side, it was not fully evaluated. We also faced some barriers. So yeah, I'm afraid I can't fully answer that question. Sorry.
We had something similar in the Energiesprong project, with not with the balconies but with the garages, which are also like an add-on that's not insulated, but it's difficult to create, let's say, a continuous insulation there, and so there had to be some small manual insulation works to avoid the thermal issue and avoid condensation, of course, and those type of problems. It's just part of the reality of some buildings where the configuration is not ideally, and you can just put a full envelope around it that's fully closed, of course. But this was integrated, by the way, in the costs that I gave, the partially manual small add-ons around the garage.
Okay. The next one is on social energy sprung. Did you perform any estimation on how the investment can stand in the case for the social housing company? Is that clear, Lieven, or do you want me to repeat the question? Lieven?
Yeah. Can you hear me?
Yeah.
Okay.
We lost you a second.
Myself for some reason. Sorry for that.
Okay. Is the question clear?
Sorry, can you repeat it, because I don't think
Yes.
I heard the next question. Sorry.
I will. Did you perform any estimation on how the investment can stand in the case of the social housing company?
I'm not fully sure that I understand the question.
Maybe I can answer, because I was I built the business case of that particular project. What actually happened was that the housing company normally gets subsidies from the VMSW, and it can get from one side the investment subsidies, so it's decreasing the investment value or decreasing the investment amount because it's a subsidy that does not have to be repaid. And secondly, they can get money, they can get loans at a negative interest rate, so they don't have to pay. They get subsidized. So that's also bringing the investment value to, I think, something like 80-something% of the total value. So actually, the money they really spend is much lower than the face value of the investment. And secondly, the whole business case was built on what is the rent that I can get from my social tenant today. What's the social rent I can get from my tenant tomorrow and in the future, which is in Belgium extremely regulated. You cannot just increase the rent. You need to follow certain steps, and it's pretty complicated. And then what they also did was even when giving the production of the electricity from the PV panels, giving it like almost for 100% back to the tenant in order to convince the tenant that the tenant was a winner too, not only from the multiple benefits point of view where he would get like increased comfort and these things, but also he would see it in his wallet. So in Belgium, the production, because the tenant, because the social housing company is the owner of the houses, and they have the energy contracts. Well, the production on the PVs could go to the social housing company, but they give it back to the tenants. And still, based on those premises, they could manage to get the EPC contract and the payback to 40 years. So it's based on real numbers. For those particular 4 houses, social houses, of course, with the typical rent income, it might be possible that in a different contingent, in a different cluster, the rents might be a bit higher, or depending on the social income of the social rented, the rents might be lower, making it the business case worse, of course. So I hope I've answered that. The next question is from the same attendee. How is the overall solution from the social housing company standpoint resilient to the type of social tenant, not always taking due care of the assigned dwelling? Even that's something that's the customer journey. That's something that you can reply to.
Yes, so exactly. So a lot of effort, as I said, was put in this customer journey and in sensibilizing the social tenants of the fact that the social housing company is doing a significant investment for them also, and improving the comfort, improving particularly the energy bill and the overall costs. So that's a way of getting those people on board and trying, of course, to avoid behavior that's not in line with all of the investments we're doing. If we are doing facade modules and then new windows, and then people putting the windows open during the winter, it doesn't work, of course. So it's a lot to do with this customer journey sensibilization. But then, of course, it also has to do with monitoring. And we are putting under, let's say, privacy law restrictions, of course. The ESCO is putting in systems to monitor the energy consumption, to monitor the comfort temperatures and so forth. And there are some agreements made that you cannot start heating at 25 degrees all winter, or that you cannot open the windows. So there are corrective measures possible if we see that the energy consumption goes beyond normal conditions too much, let's say. And of course, people will not immediately be penalized or something or have to pay penalties. But if there is an excessive consumption and it can be linked probably to bad behavior, then again, the people of the social housing company, not the ESCO, will in the first stage contact the social tenants, talk to them, trying to understand maybe there's a problem, is there some lack of comfort somewhere that means that they're doing it. Is it maybe some member families that are taking 4 showers a day, whatever, and try to then talk to them, try to find solutions. But so it's both proactively working with the tenants, and then through the monitoring systems with the control systems of temperature, of energy consumption, intervene where necessary and remind people that they also have a responsibility. And in general, of course, here we are talking about 4 buildings. Eventually, we may be talking for 100 buildings, even if there are a few buildings that are badly performing because of less ideal tenant, let's say, behavior. That fits in the overall risk, of course, statistically. Probably the 97 other buildings will be performing correctly. But that's the way we're doing it here. A lot of it has to do with working actively with the social tenants.
Okay, and then I go to the last questions raised by the attendees. Probably in Belgium, as in Poland, a public process requires more than one ESCO participating. Does a facilitator prepare the base technical documentation, the detailed concept, for all bidders, or every ESCO is obliged to prepare its own documentation?
Yeah. In this type of project, the facilitator with the customer prepares quite a detailed documentation and tender documents, but they are mainly performance-based. They will define the KPIs that are going to be used to evaluate the proposals. And certain, let's say, technical choices, there are exceptions. The fact that there has to be, let's say, a facade panels-based system installed, that has to be imposed. The fact that there have to be PV panels integrated, that has to be imposed. So there are a number of technical requirements. There are, of course, technical requirements in terms of if you then put such facade panels, that there has to be a specific system to attach them to the walls, or that preemptively tests have to be done so that the facade can support the panels. All those things, of course, will be included in the technical documents. But then the specific choice of how the panel, or what does it look like, even how thick it is, which type of insulation material, unless we are imposing, for example, circular material, but that's something different. A lot of technical choices of how to then implement it, which heating system, what's the size of the heat pump, what's the power that can be delivered through the heat pump, what is the COP, and so on. All those things are left to the implementing consortium or contractor or ESCO. So you have to do the minimum that has to do with all of the performance KPIs that you define so that you can manage your project for the next 20 years. And then the minimal technical requirements that you can A, organize the competition, and B, you can anticipate any technical and also aesthetical problems. For example, the color of the facade finishing will probably be imposed. So here in Husselt, gray. Then the exact facade finishing, is it facade, is it brick strips, is it something else that may be left still open to some extent. But of course, you have to define those things so that you get an honest competition. And not too much difference so that you cannot appreciate different bits anymore either. That's how it works.
Okay, Thank you. I see we just have a few minutes left. That's all. All the questions, I hope that at least all the questions of the attendees have been answered. I just want to say that the presentations and the recording will be shared. Thank you very much to the speakers, and thank you very much for the attendees for their very interesting questions.